on chemical nature of amino acids. Depending on chemical nature of amino acids. Depending on chemical nature, amino acids can be classified in distinct categories. The first one is neutral amino acids. The first one is neutral amino acids. Actually, these amino acids has the equal number of NH2 and COOH groups. It has suppose one NH2 group, then one COH groups, or suppose double NH groups and twice COOH groups. But the number of NH2 groups and the number of COOH groups must be same for the neutral amino acids. So what we can write? We can write that number of NH2 and COOH groups, NH2 and COOH groups are equal. Number of NH2 and COOH groups are equal. For an example, we can write, glycine. We can write glycine. And glycine has the formula of NH2, CH2, COOH. Look, the number of NH2 group is 1. Number of COOH group is also 1. So equal number of NH2 and COOH groups. So this compound is the neutral amino acids. The next one is alanine, The next one is alanine. The formula is NH2, then CH3, and the COOH groups. So the number of NH2 group is 1 and number of COOH group is also 1. So equal number of NH2 and COOH groups are present. So this is an example of neutral amino acids. Neutral amino acids. Okay. The next one is acidic amino acids. The next one is acidic amino acids. As the name suggests that the number of acid groups, the number of COOH group will be more than the number of NH2 groups present in the amino acids. So more will be the number of carboxylic acid group and lesser will be the number of amino group or the basic groups makes the compound acidic. So what we can write? More number of COOH groups, more number of COOH groups and less number of NH2 groups and less number of NH2 group. So more the number of COOH groups and less the number of NH2 groups are present makes the compound acidic amino acids. For an example, we can write aspartic acid as an example. We can write aspartic acid as an example. We can write glutamic acid as another example. We can write glutamic acid as another example. For an example, suppose I am showcasing you this compound. This is NH2CH-COOH and there is CH2COOH. This compound has 2 COOH groups and just 1 NH2 groups. So more will be the number of carboxylic acid groups and less will be the number of NH2 groups. So makes the amino acids to be acidic amino acids. And on the other hand, the third one will be of course the basic amino acids. Like arginine you can write, tryptophan is also present. So here the more number of nitrogen is present than the number of carboxylic acid groups. So the number of nitrogen is more than the number of carboxylic acid groups makes this compound a basic amino acids. So what we can write? More number of NH2 groups, more number of NH2 groups and less number of COOH groups. More number of NH2 groups and less number of COOH groups. Many examples are there. So depending on the chemical properties, acidic, basic, neutral, amino acids can be classified in distinct categories. Okay, so let's move forward. The third way of classification is depending on availability and physical importance. 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 Okay, so depending on availability and physical importance, amino acids are classified in 2 categories. One is called essential amino acids. One is called essential amino acids. One is called essential amino acids. What is this? First of all, this type of amino acids is extremely important for the growth and development of our body, but they are not automatically synthesized in human body. They are only obtained through proper diet and food intake. They are called the essential amino acids. So they are extremely important for our biological development, but they are not synthesized automatically in human body. They are only obtained from proper diet. So they are called the essential amino acids. And how many are them? They are 10 in numbers. They are 10 in numbers. So what we can write? They are extremely important. They are extremely important for the growth. They are extremely important for the growth and development. For the growth and development of our body. Growth and development of our body. But they are not automatically synthesized. But they are not automatically synthesized in human body. They are not automatically synthesized in human body and can only be obtained through proper diet and can only be obtained through proper diet. Through proper diet. And they are, of course, they are known as the essential amino acids. Many are them in numbers. Some common examples of them are lysine, it may be leucine, isoleucine it may be, methionine, threonine, phenylalanine you can write, yes, phenylalanine you can also write, tryptophan. So many examples are there as well. The next one is non-essential amino acids. The next one is non-essential amino acids. Non-essential amino acids. First of all, they are not extremely important for growth and development of our body. And they are also automatically synthesized in human body as well. So they are called non-essential amino acids. Okay, so they are not extremely important for growth and development of our body, and they are automatically synthesized in human body. They are known as the non-essential amino acids. So what we can write? They are not so important. They are not so important. They are not so important for growth and development. For growth and development of human body. For growth and development of human body. For growth and development of human body. Okay? And they are also automatically synthesized. They are also automatically synthesized in human body. They are also automatically synthesized in human body, and they are known as the non-essential amino acids. For an example, you can write glycine as well. For an example, you definitely can write glycine. It's an example of non-essential amino acids. You can write alanine. A very good information, amino acids containing sulfur is cysteine. Amino acids containing sulfur is cysteine. Okay, very good information. Okay, so let's move forward. Now we'll learn about how to prepare the peptide linkage. How to prepare the peptide linkage. What are the peptide linkages? The linkages which are being formed between the amino acids during the protein formation, they are known as peptide linkages. That means two or more amino acids, when are grouped together, when they are being polymerized, they form peptide linkage in between different amino acids or same amino acids during the protein formation. They are known as the peptide linkage. So what is this? linkage that is formed. Linkage that is formed between amino acids. Linkage that is formed between amino acids. Between amino acids during protein formation. During protein formation. During protein formation, they are called the peptide linkages. Clear? They are called the peptide linkages. Another thing, they are nothing but the amide linkages. They are just the amide linkages. They are just the amide linkages. Peptide linkages are just the amide linkage. We have learned about the amide in organic chemistry of class 12. What is the formula? So the formula of the amide linkage and peptide linkage must be the same. So what is the formula of this peptide linkage? The formula of the peptide linkage is, of course, CONH. This is CONH. This is called amide linkage, and this is nothing but the peptide linkages. Now I am showing you some examples. I am showing you the peptide linkage formation between alanine and glycine. There are three-letter short form that we have learned already about the amino acid that is present in NCERT chart. This is the alagly. This is the alagly. Let's draw the alagly. What is ala? Ala is alanine. So the IUC protocol is that we have to write NH2 at the left, then the alpha carbon, and then the carboxylic acid at the right. This is the alanine. Now write glycine. You have to learn NH2 at the left, then the alpha carbon in between, and the carboxylic acid at the right. Now they will undergo dehydration because the acid and base, whenever they come close to each other, they will undergo dehydration reaction. So the dehydration reaction will be followed here as well. So this hydrogen and this OH group will be eliminated as a water molecule. Will be eliminated as the water molecule. So what is left? What is left? The thing left is NH2. Then this will be CH3. Okay. Now follow. This will be CO. This will be NH. Then this will be CH2. And this will again be COOH. And this CONH, this group, this is called the peptide linkage. This is called the peptide linkage. This is called the peptide linkage. So if two amino acids are present, how many peptide linkage? It's 2 minus 1. If two amino acids are present, how many peptide linkage? Just 1. So I can now write a good formula. That is the number of peptide linkage. Number of peptide linkage. Number of peptide linkage is equal to n minus 1. Number of peptide linkage is n minus 1, where n equal to number of amino acids. Where n will be equal to number of amino acids. Okay? Where n will be equal to number of amino acids. So we are moving to the next example. Now this time, we will draw glyala. We will draw glyala. So, we have to draw glycine initially. So this will be NH2, then this will be CH2, and this will be COOH. This is glycine. Now we have to draw alanine later. So this will be NH2, this will be CH, this is CH3, and the COOH. Now we have to remove water molecule. We have to remove water molecule. This H and this OH, this will be eliminated as the formation of water molecule. So what is left? This will be NH2, this will be CH2, this will be CO, then this will be NH, then this will be CH, CH3, and then it will be COOH. This is the formation of glyala. And where is the peptide linkage? This is peptide linkage. This is the peptide linkage, dipeptide, but the number of peptide linkage is just the one. Now show me the formation of ala, gly, and ala. Now show me the peptide linkage formation of ala, gly, and ala. So we have to draw alanine initially. So this is your alanine, NH2, CH, CH3, and COOH. This is your alanine. Then we have to draw glycine. This will be NH2. This will be CH2. This will be COOH. Then we have to write alanine again. So this will be NH2. This will be CH. Then CH3. Then COOH. Now we have to remove two water molecules. One is from here and another is from here. So we need to remove the two water molecules. So what is this? This will be NH2. This will be CH. CH3. C double bond O. Then this will be NH. Then CH2. Then C double bond O. Then this will be NH. Then CH. CH3 and COOH. So this is and this is. These two are the peptide linkages, you know. These two are the peptide linkages. So there are 3 amino acids, a tripeptide. But the number of peptide linkages is always n minus 1, where n is the number of amino acids. So the number of peptide linkages will be 2. Number of peptide linkages will be 2. Number of peptide linkages will be 2. Let's move forward. Now we will learn about D and L amino acids. So first of all, look at the structure of glycine. Look at the structure of the simple amino acid, the smallest amino acid, glycine. The structure is NH2, then this will be CH2, and this will be COOH. This is the structure of glycine. So, is this a chiral carbon? The alpha carbon is chiral? No, because the 2 hydrogen is present. So, this carbon is not a chiral carbon. This carbon is not a chiral carbon. So, I can write that glycine is optically inactive. The glycine is optically inactive amino acids. So we can definitely say that glycine is optically inactive amino acids because it does not have any chiral carbon present. So forget about plane of symmetry and center of symmetry. Glycine will be an example of optically inactive amino acids. The next one is alanine. The next one is alanine. What is this? Let's check alanine now. And this will be NH2. So this will be CH. Then it will be CH3. And this will be COOH. Look at the alpha carbon. This alpha carbon has 4 distinct groups. One is NH2. Another one is COOH. Another one is H. And another one is CH3. So 4 different groups are present in this sp3 carbon. So this carbon is chiral. There is no POS, no COS, no plane of symmetry, no center of symmetry. So we can clearly write that alanine is an example of optically active amino acid. This is an example of optically active amino acids. This is an example of optically active amino acid. Hope this will be okay for you. Hope this is good for you as well. Okay, so let's move to some good, interesting chemical properties of amino acids. So I'm writing the chemical properties of amino acid. The most important few chemical properties of amino acid we will write now. The first chemical property of amino acid is the formation of Zwitter ion. The formation of Zwitter ion. The formation of Zwitter ion or dipolar ion. The formation of Zwitter ion or the dipolar ion. Formation of Zwitter ion or the dipolar ion. Okay. Suppose I have this amino acid in a container, you know. This is NH2CHR and this is the chiral carbon. So this is the amino acid present here as well. This is the amino acid present here as well. So this is the formation of Zwitter ion or the dipolar ion. This is the formation of Zwitter ion or the dipolar ion. Let's try the formation of Zwitter ion. This is the neutral amino acid present. Now how Zwitter ion is formed, what is Zwitter ion, we will learn gradually. So let's focus on these neutral amino acids now. Suppose I am putting this neutral amino acid in a very low pH medium. Low pH medium I am keeping this amino acid. So low pH medium is acidic. So acid means what will happen? Tell me, acid means what will happen? Acid means H plus ion will be more in concentration. Okay, so what will happen? the nitrogen will use the lone pair to catch the H plus now. And whenever a base accepts proton, it will be converted to conjugate acid. So it will be NH3 plus, then this will be CHR, and then this will be COOH. This is the conjugate acid of these amino acids, you can write. This is the conjugate acid of the amino acids. Next one, suppose I am keeping this neutral amino acid in high pH medium. In high pH medium. High pH means basic and base means OH minus ions are present. High pH is basic and base means OH minus ions are present. So in the OH minus ion, what it will do? It will snatch the H plus from the solution and it will be converted to NH2, CHR and COO minus, NH2, CHR and COO minus. So whenever acid loses proton, it will be converted to conjugate base. Whenever acid loses proton, it will be converted to conjugate base. So we can write this is the conjugate base of the neutral amino acids. Now the third criteria. Whenever this amino acid is kept in intermediate pH, whenever the amino acid is kept in intermediate pH, what will happen? This will be NH3 plus, this will be CHR, and this will be COO minus. NH3 plus CHR, COO minus. NH3 plus CHR, COO minus. What is this? This is a dipolar ion because we are availing the intermediate pH. So you know equal concentration of H plus and OH minus. So equal reactivity with NH2 and COOH. So we can form this important ion. And look at this ion. This ion has two ions, cation and anion both. This compound has two ions, cation and anion both. So this is called the dipolar ion, or this is also called Zwitter ion. This is the dipolar ion and this is also called Zwitter ion. So actually amino acid is present in this ionic form. It is not present in the neutral form. Amino acid basically present is Zwitter ionic form or the dipolar ionic form. Okay, now we will learn some chemical reactions and also some equations which is related with ionic equilibrium of class 11. So let's focus on our next page. So where I am writing the first ion form, which is this one, I am writing the first ion form, that is the conjugate acid formed. What is this? This is NH3 plus, then this will be CHR, and this will be COOH. Okay. So the next ion is the Zwitter ion formed. So for the formation of the Zwitter ion, what it should do? It will lose this proton. So I can write this reversible sign, one proton lost, and the Zwitter ion, that is NH2. Okay, then this will be CHR and COO minus. Okay, the next one, now in the solution the Zwitter ion is present. This is NH3 plus, then CHR, and then COO minus ion is present. Now this ion is being formed to the conjugate base. This ion will be formed to the conjugate base. So what we can write? So it will lose another proton. It will lose another proton, this time from this NH3 side. So it will be converted to NH2, then CHR, and then COO minus, and H plus, and H plus. Okay, so the first reaction, one H plus is lost. The second reaction, another H plus is lost. So in the two equations, the compounds are showing the acidic characteristics. In the two equations, the compounds are showing the acidic characteristics. So say that the equilibrium constant for the first reaction is K1 and equilibrium constant for the second reaction is K2. This can be K1 and K2 in your question paper. Issues about that, it may be K1, it will be K2, where A suggests acidity. Yes, both the reactions show the acidic character of this compound. So this is your conjugate acid. This is the dipolar or the Zwitter ion. This is again the dipolar or the Zwitter ion. And this is the conjugate base. This is the conjugate base, guys. So what will be the expression for K1? Tell me. From the ionic equilibrium, K1 will be the active mass of RHS by LHS. So what it should be? it should be H plus into dipolar ion divided by, we can write the conjugate acid. Say this is equation number 1. And for the other one, the K2 will be, it is conjugate base concentration into H plus concentration divided by dipolar ion, and this is the equation number 2. This is the equation number 2. Clear? Now, what we can write now? When the dipolar ion is formed, look at very carefully. When the dipolar ion is formed, the equal charge density of these cation and anion is present. So we can write that the conjugate acid concentration and conjugate base concentration is the same, because in the conjugate acid NH3 plus ion is present and in the conjugate base COO minus ion is present. So in the Zwitzer ion or in the dipolar ion, equal concentrations of NH3 plus and COO minus, these ions are present. So we can write now at a certain pH, we don't know what will be the value of the pH, but we can definitely write that at the certain pH, the conjugate acid concentration and the conjugate base concentration will be the same. So from this equation number 1, what is the conjugate acid concentration? This is the H plus concentration into dipolar ion concentration by the K1 values. What is the conjugate base? This is the K2 value into the dipolar ion concentration divided by the conjugate base concentration. Now this di and di will be cancelled. So what we can write? That is K1 into K2. That will be equal to what we can write? This will be K1 into K2. And look at the Ca concentration again, H plus into di by K1. And what is the Cv concentration? This will be K2 into di. K2 into di by H plus. So this will be H plus. This will be H plus. So as you cancel di and di both, what we are getting? This will be K1, K2. That is nothing but equal to H plus whole square. This will be nothing but equal to H plus whole square. Put log on both sides. So log K1 plus log K2, that will be equal to 2 log of H plus concentration. You please consider the base of the log as 10 only. Okay. Now put minus sign on both the sides, please. So this will be minus log K1 to the base 10 minus log K2 to the base 10. That will be equal to minus 2 log H plus concentration to the base 10. Now what is this? This is pK1. This will be pK1. What is this? pK2. And what is this? pH. So what is the formula of the pH of this particular zone? This will be pK1 plus pK2 by 2. So we can write that this pH is a certain pH of the solution where the Zwitzer ion can be formed, and the value of this pH is pK1 plus pK2 by 2. That is just the average of the respective pK values of the Zwitzer ion as well. Now, what is the importance of this pH in chemistry biomolecules? Suppose the pH is maintained in the solution. I am talking about this pH. Suppose this pH is maintained in the solution. So at this pH, the Zwitzer ion will be formed. Okay. At this pH, the Zwitzer ion will be formed. And if I do some electrolysis with the help of the Zwitzer ion, look at this Zwitzer ion. Both cationic part and anionic part are present. So eventually the ion is neutral. So during the electrolysis, will it move to the cathode or else it will move to the anode? Nothing will happen because eventually the compound is neutral. It has equal tendency to move to the cathode and anode as well. So eventually it will go nowhere. It will go nowhere. So no electrolysis product will be obtained. So this ion can move neither to the cathode nor to the anode at this pH, whose value is this, and this pH is called isoelectrical point of the amino acid solution. This pH is called the isoelectric point of this amino acid solution, and the value of isoelectric point pH is pK1 plus pK2 by 2. So let's write the definition of the isoelectric point, guys. So I'm going to write the isoelectric point. I am going to write the isoelectric point. Isoelectric point. What is this? This is the This is the pH of a solution. This is the pH of a solution of amino acid. This is the pH of a solution of amino acid. When during electrolysis, come on, the amino acid will move. The amino acid will move neither towards cathode or anode. The amino acid will move neither towards cathode or anode. Neither towards cathode or anode. So during electrolysis, the amino acid will move neither towards cathode nor towards anode during this electrolysis. And what is the value of the pH for the isoelectric point? So this pH of the isoelectric point can be written as Pi, where I is the isoelectric point. So this will be pK1 plus pK2 by 2. This is just the average of the respective pK values of the amino acid medium. And it's so easy to understand that this pK value will be provided in the QP.